In this video, we're going to look at the final method of passing parameters to a function or a subroutine. Now we're going to use this little example here. Now what this does is it takes two numbers, it finds the largest of those two numbers and just returns the largest value. So we've seen this program before whenever we looked at passing parameters to a subroutine using values. So we're going to do the same thing here. We're going to pass by value, but we're going to use the stack in order to do the passing. So we're going to have two numbers here. So we're starting off at the top of this little bit of code. We're going to have one number in address 8150 and another number in address 8151. So these are just basically two random numbers we've got somewhere in our memory, and we want to make a comparison and find out which one's the largest and return that largest value. So you'll see here at the bottom, first of all, we've got our start address 0x8100, and we're going to set up these three defined storages. So we've got the DS1, which is the return address, which is of length 1 byte. DS2 is save first, and DS3 is save second. And we're going to have our two values here that we set up called first and second, which are the addresses of the two values that we want to compare. So we take the contents of the memory address first and we load them into R0. So the memory address first is just this address of the first number. So we're going to load the contents of that memory address into register R0. So we load 20 into register R0, and then we push that value onto the stack. So we put the 20 onto the stack, and then we do the same for the 10. We load it into register R1, and we then push register R1 onto the stack. So we'll now have the values 20 and 10 on the stack. We then jump to the subroutine to find the largest of those two values. Now whenever we jump to the subroutine, again it's going to subtract a value off the stack and it's going to save the return address in that stack. So we're going to have three values in the stack, the value of 20, 10 and the return address. So now we go through the process here of finding the biggest. But now we're able to get the parameters not from the registers but from the stack. So we can pop the first value off of the stack, and remember the first value that's going to come off was the last one that went in. So the last one that's gone in is going to be the return address. So we store that in a local memory location called return address. And again, we then pop off the value, the next one that went in, and we store that in save second. Okay, so it's going to be the second value. So it's going to be the value of 10. And then we pop the final one off and we store it in save first. So we're just popping the values onto the stack and they're there waiting for us within our subroutine. When we get into our subroutine, we can just pop the values back off and we can save them as in a local storage. And we save them as save second, save first, and the return address. So now we're ready to do the compare. So we can compare the values save first and save second. So remember the compare here command that I've generated here is actually going to compare the contents of the memory location save first and save second. So it's going to compare 20 and 10. Now we go through the jump if A is greater. So if A is greater, it will jump to this A big. Okay, now if A is not greater, then it will just continue with the code. So this is a point where we do the comparison, and there's two options that we're going to have here. It's going to be greater than, or it's not greater than. We're not bothering about equal to at the moment, so we'll just leave that out. So it will jump then if A is greater than to A big. So whenever it jumps here, it's going to push the value of R0 back onto the stack. So remember, we've still got a copy of R0 and R1 in the registers. So we push the value of R0 onto the stack, and then we jump here. Now you'll notice here we're using this jump to return address. We don't actually have a return function in here because we've lost the return address. We've already popped it off of the stack. So, but we can just return to this return address here. So the curly brackets here tells us that we're not actually jumping to return address. We're jumping to the contents of return address. So the contents of return address is the actual the point that you want to return to. So it'll return back up here just after the biggest, and then we're able to pop the value of R2, which will be the largest value, off of the stack into register R2, and then we can jump to the end. Now if it was the other case and A wasn't bigger, then we would push the value of R1 and then jump back to the return address, which again is up here, and we would pop that value off and save it in register R2, and then we would end the program. So that's the basic flow. Maybe difficult to see here, but what I've done is I've drawn it out in a little schematic of it, and I'll show you that schematic now. So we have our general memory here, we have our registers here. So let's call this register R0, R1 and R2. Now we're going to start off with two values already in memory. So we're going to have, say, a value of 20 here and a value of 10 here. And this is address 8150 and 8151. So these are just two random values and two random memory locations, and we're going to compare them. Now we can take the first 120 and we can put it into register R0, and then we can push this value onto the stack. So let's say the stack starts at this point here. We can then take the next value here, 10, and put it into R1, and we can push this onto the stack. We're now ready to jump to the subroutine, so we jump into the subroutine. Now whenever we jump to the subroutine, we save the return address in the stack as well. So that's going to be 8000 in E in this instance for our piece of code. So now we've got three values sitting in the stack, and we're inside the subroutine. We can then get these values into the subroutine. So all we need to do is pop the values back off the stack. So we can take 8000 in E and put it into register R0. And then we can take this value here and we can place it inside a memory location. So this in effect will become our local memory inside the function. So we can take our 8000 in E here and we can just call this ret. So in the code it was called return address. So this is the return address here. We can then pop the next value off. So the next value off is the value 10. But remember, the value 10 here is the actual second value. So this is actually going to be our, we could call it save second. And that's going to be the value of 10. So we're going to put the value of 10 in here. So that's quite important because the way that we put values into the stack, we're going to take them off in the opposite direction. So we can get in and get the next value here, which is our value off the stack, which is 20. So we can put our value here, 20, back into R0. And of course this value here is being copied over as well, as the 10 goes into here, and from here it goes into this point. So the 20 goes into register R0, and then from R0 it goes into the memory location here. So that's going to be our save second. Save second. Okay, so we've got our three values here sitting in, if you like, local memory, which are our copies for us to use within our routine. So we can then go through the compare function and we compare the save second and the save first. So we compare these two numbers here. So we're not actually comparing them at this point here or this point, we're comparing them at this point here. So after we've done the comparisons, we've got two options. We're going to jump if A is greater to one part of the code, and then if it's not greater, then we're going to jump to another part of the code. So let's bring the code up here quickly just as a reminder. So that's the code here. So if I make this a little bit smaller and bring it up. So if A is greater here, jump if A is big, so we jump down to the big part here. So in that case here, what we do, if the A is greater, then in this instance the save A is going to be the register R0. So we push the value in register R0 because we've still got copies of them. We've still got 20 in here and 10 in here. So we can push the value of register R0, which in this case is the largest, onto the stack. So again, we've already taken these values. In effect, these have been taken, they've not been taken off the stack, but the stack pointer is now pointing just to the bottom of the stack here, which is FFF0. So what we can do is we can put the value 20 back onto the stack. So it goes back onto the stack here, and the stack pointer then points to it. And then we can head back up to the part here. So it does the return. So it jumps to the return address. So it jumps back up to the return address up here, which is just after the call function, to the call to the jump to subroutine. So it jumps up here and it pops that value off of the stack and puts it in register R2. So it pops the largest value off here and puts it into register R2. Okay, so we'll end up with a value 20 here. Okay, now if it's the other way round about, if it's not bigger, then it's going to push the other one onto the stack, so it'll push the value R1 onto the stack. Okay, and then whenever we pop the value back off at this pop R2, it's going to pop that other one. Okay, because the other one in that instance would be the largest. So it might seem a bit contrived, okay, and probably in this particular instance it's a bit unnecessary, but if you had dozens or potentially hundreds of values and variables that you're passing in and out, it becomes a very neat and efficient way of passing information in and out of functions. So let's have a quick look at it working on the CPU. So I've loaded up the CPU with the program, and you've got access to everything you need within the resources section to run this for yourself. So the first thing we're going to do is put our values of our 20 and 10 in our memory locations. So that's the instruction 200. And we'll get in here just in a second once those have passed in, and we'll have a look at them and make sure everything's sitting where it should be. So we're going to have our values then, if we can have a look. So we've got our value of 20 in here and our value of 10 in here. So these are just our two random memory locations holding two random numbers. We then take our value of our 20 and we put it in a register R0, so that's it here. And then we push that value onto the stack, and you see the stack pointer dropping by a value of 1. We then get in and we grab the other value, which is our 10, we put it in register R1, and then we put that into the stack as well. So now we should be sitting with two numbers in our stack, our 10 and our 20, and we jump to our subroutine. But when we jump to our subroutine, again, it takes one off of the stack. And if we head in, we'll be able to see that the stack now should contain the values, which are our 20, 10, and our return address. So now we're inside the stack, we can then take the start popping the values off. So we can pop the first value off of the stack, which is going to be our 8000 in E. You can see it here. So we put it into register R. Well, it gets popped off of the stack, and we save that value in a local memory location. And we do the same for our values for our 10 and 20. Those get popped off of the stack and they get saved in our local memory locations. So we'll get in just a second and we'll see them sitting here in our local memory. So if we come in here, you can see that our values of our 8000 in E, our 20 and our 10 are sitting in our local memory locations. So if you like, these are our local variables which are available to us within the subroutine or within the function. Now we're going to make the comparison, so we'll make the comparison between this one and this one. So that's the next function here, you see. And we should have an A is greater than B coming up when we go through this comparison. And you see here A is greater than B. So if A is greater than B, then we're going to jump. Okay, so we go through the jump here, and we should jump if you look at the code. So we jump here, jump if A is greater to A big. So we jump to A big. Now at this point here, we know that the save first is the biggest one. Because that's just the test that we've just done. So we then pass the value there that's in register R0 out because it contains the largest. So we're going to push that in onto the stack. So we push the value 20 onto the stack. So remember, we'll have taken, or the stack pointer has gone back to the beginning of the stack. So we have to load that value back into the stack. And then once it's loaded back into the stack, we can then jump to the return address. So we then jump back up to the instruction after the jump to subroutine, and it pops that value off of the stack, which is the largest value, and puts it into register R2. So we'll see that doing that now. So if it works, it should take the 1,4 and put it into register R2. And you'll see it just working through now to get this 1,4. So that's 1,4 goes in, and then it should jump to the very end of the code, and you can see the stop coming in. So that's it, picked that value 420, which is the largest value. So it does work, and if you try it round the other way, you'll see that it works as well. So you can download this code yourself, and you can play about with it, and you can put different values in for the data here. So rather than using the value of 20 and 10, you can use different values and change them round about. So it's a little bit contrived, but it does show you that you can pass values into the stack. Okay, you can put values onto the stack, you can push values onto the stack, and then you can pop them off inside the function. And then you can push values onto the stack inside the function, and you can pop them back off outside the function. So it's a very neat way of passing information into the functions or subroutines and getting information out of subroutines back into the main calling function. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.